We're going to start working on our Chapter 9 exercises. The first exercise that's assigned this semester is exercise 9.4. So let's read this really quick. It says, implement a class address. An address has a house number, a street, an optional apartment number, a city, a state, and a postal code. Define the constructor such that an object can be created in one of two ways, with an apartment number or without. So you don't have to do one or the other. You get to pick, right? Because sometimes you have an apartment, sometimes you don't. Supply a print method that prints the address with the street on one line, the city, state, and postcode on the next line. Supply a method called comes before that tests whether this address comes before other when compared by postal code. All right, so kind of have our roadmap here, so we're going to do this in bits and pieces. So the first part is, now you have to remember, we're going to build a class file here. So we're going to build the file that allows us to create the object, but we are told that it has to have certain capabilities by this definition. So we might bounce back and forth to this a little bit, just as a reminder. But I've got my Spider open. In my file folder, when I go to do a save as, I'm going to create a Chapter 9 folder. So I'm going to go into my Google Drive here where I'm storing things. And I'm creating a new folder, Chapter 9. And then all my work is going to go into that folder. The first exercise I'm going to call exercise 9_4. And you know what? That was a mistake. Yeah, because I'm just thinking to myself, if I follow the examples in the book and I'm like calling objects, I have to call the file name, and calling it exercise 9.4 doesn't really mean a lot. So watch what I'm going to do. So I apologize. Yeah, I'm going to save it as a different name. So I'm doing a save as again. I'm going to call it address. Because you know what? That makes sense as a class name. So I'm going to call it address.py, all lowercase. Okay. All right. So the first thing I'm going to do is I'm going to follow the conventions in the book in terms of what is considered a good way to code a class to develop a public interface so another programmer looks at it, they can tell what it's doing right away. So the first thing I'm going to do, I'm going to blow away all the comments at the top here. And I'm just going to say this. This module defines the address class. All right, it's kind of considered a little bit of a convention. The next thing I'm going to throw in a form of comments is, what does this thing actually do? It says an address that stores house number, street number, optional apartment number, city, state, and postal code. So somebody looking at the top of this, right off the bat, boom, they see what's going on. Right? No guessing. It's plain to see in the comments. All right, so if I'm defining a class, I guess I better start by defining it. So let's call it class, and we're going to call it address. And I'm using uppercase for the actual class name, for the first letter. The next thing that I'm going to do is, in this spot, I'm going to go ahead and actually define all my instance variables like this. So if you follow the conventions shown in the book, they do this. Just like that. And it says constructs an address without an apartment number. Okay, so there's a parameter for house number, street. It just kind of lists all those things. Now, if I was writing a Java program or C++ program, I would create my variables up here and call them privates. But what this is kind of a workaround to tell the programmer who might use this, especially when they use a constructor function that follows, because that's what it is defining really. It tells them, you know, what stuff is inside there before they even broach it. So on the following line, since I'm defining the constructor function, I'm going to do this. And I want you, this is a little more complicated than some of the book examples, but it's pretty easy to follow, honestly. So what we're saying here is we're defining the constructor, which is underscore, underscore, init, underscore, underscore. Then the first parameter we pass is the self-referencing parameter. And then everything else is a value that we're going to pass in. So in other words, we're going to pass in the house number, the street, the city, the state, and the postal code. And because those are just listed as they are, they must be passed in. The last one, the apartment number, because it is listed with apartment equals double quotes, we're pre-passing a pre-configured value, so we could either leave it alone if we don't have an apartment number. So if you live in a house, you probably don't have an apartment number, so you wouldn't pass in that value. But if you did have an apartment number, then after the postal code, you'd throw in the apartment number, and then it would populate all the variables inside. So we'll do these one at a time, just so you can see the procedure here. So now we have to go through, and for each one of these, so first we're going to do house. We're going to define that in the constructor. So we're going to say self dot underscore house. The underscore house indicates it's a private, right? Or at least by convention. And then we're going to assign to it whatever was passed in. So the value that's passed in will get stored in underscore house. House and underscore house are two different things. House is the value coming in from the outside world. Underscore house is the value inside the object after it's created. And if we want to access that or change that value at any point, we have to do it with underscore house. In very much the same way, you can probably guess that all the others will follow the same pattern. So go ahead and start dropping them in. You've got street, apartment, city, and heck, city, state, and postal. State and postal. Make sure your indents are congruent. Python's not too picky about how many spaces you indent, as long as you're consistent. You guys have probably figured that out on your own. But I'm copy-pasting from like one text editor to another, and they indent differently. So that's why sometimes mine are off. So this is the constructor function, folks. And that's why it says here, constructs an address without an apartment number, boom, 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 boom. And then if perchance there is an apartment number thrown in, it will attribute to apartment. If there, otherwise apartment will be an empty string. All right. Next thing that we need to do is go back to the program description. I'm trying to get back to that first line, but I keep backspacing one too many times. All right, there we are. And see what the next instruction is. And if I remember right, it says define a constructor. Okay, we did that. Then it's to supply a print method and supply a method that checks to see if it comes before. So we got a print method and a comes before. So let's work on the print method first. That shouldn't be too bad, okay? So the first thing I'm going to do is I'm going to indent the right amount of spaces here. I'm going to create a new definition. And you know what? I'm going to call it print. Now you should say to yourself, you can do that? Doesn't Python already have a print? Yeah, but this is a print method relative to this object. Not comfortable calling it print, call it something else. But you can do that because this is not calling the standard Python libraries. All right. Now, to print out a street address on one line, so the street number and street, right? And then city, state, and postal code on another line. I think that's pretty easy to do, right? I think you just read in the variable and you put it up on the screen, right? Right. But the only little contention that we have here is dealing with that apartment number. So I'm going to start by actually doing an if statement. I'm going to say if the apartment variable, the instance variable, does not equal an empty string. So in other words, they passed a value in. If that's the case, then we'll do a print. We'll say print, and I'm going to throw a little formatting in here. And if you guys don't remember your formatting, you can go look it up again. I'm going to do this. And then I'm going to call the variable. And then I'm also going to keep it on the same line for right now. All right. Didn't mean to move the paren. Then I'm going to go back and indent. And now I'm just going to do the regular print statement. So that's only going to print the apartment number if necessary. Otherwise, I'm just going to print self.house, self.street. That would be one line. And then the next instruction is to print. I'm going to do a little bit of formatting here. And so what this is, and I don't know if you guys remember this format thing, but this is saying print the text, a comma, print the text, print the text. So it looks like an address, right? You go city, comma, state, space, zip code, typically. And then we'll actually tell it what we're putting on screen, which is going to be self.city. And you guys notice that how the auto sense on this, after I type self and go dot, it knows to look back unto itself and pull it back the list of all the stuff that I have available inside my class, and it does that automatically. That's through the dot syntax that's available. So then we add city, state, and self. And you know what? That's all it takes to print it. Now, I'm not sure that's necessarily where I would put the apartment number. Like, if I was typing the apartment number, I think I would probably put it at the end of the street thing, you know. So if you wanted to do that, I get it, that's fine. I'm just copying what the author did here. I'm not saying it's the best way to do it. All right, next thing that we need to do is we have to write another method that tests to see if one address comes before another. And something else I forgot to do here, now that I think about it, is this. Is we should have put in a descriptor for that function. That way, another programmer looks at it, he knows what this method does. I think it's pretty intuitive on that one. And you know what? We better be like pretty good about this and put something in for the next one right away. So the next one, we're going to see if one address comes before another. So they already told us what to call it. In fact, they even told us what parameters should go with it. So I'm just pasting it in. Just got that right from the problem description itself. And then because street numbers are numbers, it's really easy to see which comes first. In fact, we can just say if one postal code is less than the other postal code. Now, we didn't talk about that term other, but other is the value that we're passing in, if you can see from the parameter call. And so I thought they were checking street addresses, but they're actually checking by postal code. Now, why would they do that? Because in terms of a postman delivering mail, right? They don't just like walk into the post office in the morning and here's a whole bag full of mail, good luck, go, right? I don't know if you guys know anybody that's ever worked at the post office, but before the postman goes out and delivers the mail in the morning, they have to take all the stuff that's like in like certain neighborhoods, and then they sort it by postal code, by street number, and that way when they walk up and down the street and they put it in your mailbox, all the stuff's already in order. They're just putting it, they're just pulling it like in order from their sort. And some facilities pre-sort it for the mail carriers, and sometimes the mail carriers have to do it themselves. But it's always the job of the mail carrier to double check it. And what I'm reading from this little method here is it's seemingly designed for a postal carrier to sort their mail, so if they're delivering more than one zip code. So I think that's kind of interesting. Believe it or not, that's all the code, folks, for this one, for the class. All we have to do with this is save it. Well, here's the problem with the class file, though. If I hit the run button, should I do it? Here, let's do it. Did it, yay. It doesn't do anything, right? It does not have a main method that executes any code. The only way that this operates is if a different program calls this file, creates an object based upon it, and then invokes its methods. Okay? So here's where hopefully the aha comes. We'll find out. So now we need a program that's going to test it. So here's how we're going to do that. We're going to create a new file, save it in the same folder, so do a save as. And I'm going to call this demo address or test address or something like that. All right. And then following the convention of what the author would like you to do, I'm just going to copy his code. The first line in this test program is to import from address, the file, the address class. Now I do see that it has a little thing here. It's imported but unused. Well, yeah, duh. We haven't used it yet. We just typed the import statement. So don't freak out to that. First thing we want to do is construct not one, but you know what, a couple of addresses so we can really see that it's working. And in fact, we need at least two so that we can compare, right, to see which one comes before. Here's how we do that. Here's one example. I'm going to set up a variable, and inside that variable, I'm going to store the result of the constructor for the address class. So it's going to go out to the address class, and because there's parentheses following, that means it's going to invoke the constructor. The constructor will receive all the values that I've typed in here. So 2500, University Drive, some city, some state, some postal code. And now all of that is stored in A as an object. Okay? Let's create one more. Let's creating an A, let's create a B. So here we have the constructor for the second address. So different street number, different street, some other city, some other state, some other postal code, and if you notice at the very, very end of that line, an additional number, which is the apartment number. All right? First thing we're going to do is, now that we've created these two objects, is now we're going to go ahead and try the print method from the object itself. All right, so here we go. I'm just going to say demo the print method. The first thing I'm going to do is I'm going to use Python's print method, and I'm going to say the address is, oh, actually, so this is, okay. How about address, so we know which one we're looking at. We'll say address A is, that'll be our first output. Then on the next line, we're going to call the object named A, and we're going to invoke the print method. And I want you to notice what's happening here. Is I typed A and did a dot. It recognized right away that that's an object, and then it shows me all the stuff that's inside that object. So this list that just popped up is a list of the stuff inside that object. The stuff at the top are the methods. The stuff at the bottom are the instance variables. All right, so we're going to call print. We're going to use our parentheses, and we don't have to do anything else. It's going to do the rest of it automatically, because it's going to go back to this file and say, what does print do? Well, it does this. And so from the demo program, that silly looking simple statement there is actually in disguise doing all this. And it could do much more. It just depends on what you code in.
I get a name error. So self is not found.
Self is not found. All right, Tom, let me get a look at that. And where are you getting that on? From the on-the-fly debugger on the side?
Yeah.
In that case, go back to the method and make sure that you've included self here.
Yeah, I got it.
All right, and then check all the other references. And if that still doesn't fix it, we'll take a look at it in a minute. All right. Then the next thing that I'm going to do is I'm also going to do another Python print command just to create a new, fresh line, so we have a blank line. And then you know what? I'm going to do the same thing for the B address. I'm just going to copy all this code. I'm just going to say the B address is, and I'm going to change A to B. And you know what? Let's save this. Let's actually go ahead and run this right now. I'm going to run it. And you can see address A is, and address B is. And I'm not liking what they're doing with the apartment number. And you know what? If it was me coding it, I wouldn't put that there. In fact, can I fix it? Are you guys okay if I fix it? It's bugging me because I think it's so dumb. I think the technique is right. You can only print the apartment number if you need it. But it doesn't make sense for me to put it there. It makes sense for me to put it after the street. So I'd put that statement here. And then I would actually, instead of doing a line continuation on the apartment number, I would do the line continuation on the street number. But that, oh, I see that, why that's a problem though, right? Yeah, that's probably not a good idea, because in this, the city, state, and zip will be there too. So we can say if there's an apartment number, maybe we could actually output apartment number like so. The other, I'll tell you what else I don't like. I don't like the fact that he's, or she, is using print as the name of the print method, even though that's what the book said to do. I think that's like not in really great taste. So I'm going to say print address. Are you guys okay with that? All right. All right, and this one's giving me an error here in the formatting. Oh, that's because I'm printing multiple values. That should fix it, right? All right, what's my right syntax here, folks? Do I go like %s, %s? Does that fix it? No, because those are all variables. All right, I'm actually going to simplify it and do this. Okay, so now I figure out afterwards how I could have fixed it. Oh, there it is. All right, so I fixed the print method, I moved the address down, so it'll be on its own line if it happens to need to be. Let's save that class. Let's go back to the demo program. Now, anywhere where I called the internal method, I have to change that to print address. Just like that. Let's save that and let's test it again. All right. I want you to notice in the console window too, it said reloaded modules address because I changed it. Right? It's not an error message, it's just telling you. All right? So you see how the second one now prints the apartment number? So I think that's a little better than what they had, output-wise. One more thing we have to test. The next thing that we have to test is we have to demonstrate, so I'll just say demo the comes before method. And here I'm just going to say print and I'm not liking how the author is doing this. You know what? I'm just going to show you what he's doing, and then you tell me if you like it. Because I don't. He's doing this. He goes, A comes before B is... Huh. What is that supposed to return? What is that returning, actually? If I'm checking to see if one value is less than another, it's going to return what? Think Boolean. True or false is really what it's returning. So it's saying, is the first value, does it come before the second value? So that's why they say here, in the demo program, A, in fact, I might say something a little more verbose. Address A comes before address B is either true or false. This is either true or it's false. All right, so let's go ahead and run that now. So the only thing that we have to do is on object A, we can pass to it object B. And this is really actually a whole lot more powerful than you guys realize, because in our first example of a class program, we're actually passing objects around. So we're sending B as an entire object over to this method, and then it just pulls a portion of it out here, the postal code, and checks to see if one comes before the other. Now we should know 1, 2, 3, 4, 5 is true that it comes before 99102, right? So when I go to run this main demo version of the program, make sure it's saved, it should output address A comes before address B is true. All right, folks. And then the output that you see here shows the completed working program. So it's in two pieces. Here's our class file in its entirety, almost its entirety. Here is the demo program in its entirety that proves that it works. So that was the first exercise. Let's see what our next exercise is. You think I'd have these memorized. But the next exercise is 9.5. 9.5 says, implement a class soda can with methods get surface area and get volume. In the constructor, supply the height and the radius of the can. So they're not saying a lot here. But here's the implication. We're going to write a class that creates a soda can that also helps us determine the volume and the surface area of the can. Those are just math formulas that you can research. So if you don't remember how to get the volume of the cylinder or the radius or the surface area of a cylinder, Google it. You know, find the formula, look it up, and then convert it into a Python formula. I'm going to kind of save you the step here because I have the solutions already, so you guys don't have to Google it. You can just follow the video. And I just want to make sure that I'm looking at the right chapter, and I'm not. All right. So the first thing that we have to do is this. Let's create a new file. And following kind of the convention that the author is using, I'm just going to blow away all this stuff here. And I'm going to go ahead and do a save as. And I'm going to actually call this one soda can. Okay? And yeah, let's get soda can. All right. The first thing that we're going to do is drop in some comments at the top so anybody looking at this can figure out how to use it. And it says this module defines the soda can class. That sounds good. Now, if you research the math on this at all, you're going to discover that you have to use this mathematical thing called pi. You guys remember that? Which is like 3.1415926, blah, 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 blah. So I remember off the top of my head. So I could either like hard code that number in an approximation, or I can just pull it in from a math library. So here's what I'm going to show you is we are going to pull it in from a math library. We're going to import from math pi. Now that should sound familiar. So really all that math is a file that holds a bunch of mathematical formulas, right, that somebody else wrote for us, so we don't have to do it ourselves. It's really as simple as that. So I'm putting that in because we know we're going to use it. The next thing I'm going to do is I'm going to show a little overview of the class in a comment. So I'm going to say a soda can that has a height and a radius. That's what this does. Then I will define the class. I'll say class soda can. And then for this class, I'm going to need a constructor function. So my constructor function will look like this. First thing is a description. So we're going to say constructs a new soda can. We're going to throw in the height and the radius of the can. So then in the constructor function, I'll begin by defining it as follows. So I'll call the init constructor, pass into itself height and radius, and then I'm going to set each one of those variables to whatever is being passed in. So we're going to do self height, self radius. If you want to type it manually, you can. And that's the constructor. Nothing else really needs to happen there. Next, we're going to put in a method that computes the surface area, and then another method that computes the volume. Right? And believe it or not, those are both pretty simple formulas. I'm not saying you should remember them, from school, but some people do. But I think for most normal human beings, you probably have to look it up. And so I'm creating a method now called getSurfaceArea. And because height and radius are preset, I don't have to pass anything in. It's just going to be self-referencing. And then all this method is going to do is it's going to return the result of the math. So I'm just going to type a return statement. And then I'm going to put in the formula, and rather than mistype it, I'm just copying it in. Here's the formula converted into a Python format. You can see how it incorporates the radius and the height. So one is to determine the area of the circle, right? How big the circle is, and then, so you get like the two ends, right, of the can, and then you got the rounded surface on the outside, and all that math is included there. Next, we'll work on getting the volume of the can. So let's try paste in a descriptor there for that. And then we're going to create a new method called get volume. And then once again, we're just going to do a simple return statement with the formula. And these formulas are of course interrelated because we're working with circles and cylinders. And to get the volume, here's the formula for that. So I was looking at the problem description here, and they don't say anything about writing a demo program to test it, but that's exactly what we're going to do, because I think it's kind of implied. So if you look at the code that we have here, this is basically complete, right? Because it does all the things we need. It creates the object with the height and the radius, and then if you call either one of the internal methods, it will just return whatever that value is. So now we need a program to test it. So let's go ahead and create a new program. And this one I shall call, follow the pattern here, demo soda can. All right. So in this one, I'm not going to worry about all the comments here, so I'm just going to kind of create it from scratch. The first thing we want to do is we want to import, what are we importing from? Soda can, import, what are we importing? Soda can. And how did I spell it? Did I do all caps there? Capital S, capital C. So those do have to match up. The first thing that we want to do is just like we did with the address thing, is we want to construct, right? So let's put in a comment. Construct a couple of cans. So I have a really clever name for them. Why don't we call them Can 1 and Can 2? So in Can 1, how do I instantiate a soda can object? What should I type here? Yeah, so we would just type soda can with parens, but here's the difference between what we just did. This does require a height and a radius. Okay. Nobody's indicating to me what units we're using, right? Nobody's saying it's like millimeters or whatever, okay? But let's just say it's millimeters. Is that fair enough? Because that's a metric and the math is a little bit easier. So we'll say that the height is, I don't know, 20, and the radius is 5. Let's make another can object called can 2. Same type of syntax. And this time we'll make it, I don't know, 30 tall and a radius of 10. Now to just demonstrate that the math is working for each one of these, so I'm going to now say can 1 dot, and see, this is the beauty of object-oriented programming, is because I have the object created in the same folder and I have it imported, by just typing the name of the object I've created, now it's pulling back the methods that are available. So let's first pull back get surface area, and you guys will say, well, that's great, you're getting the surface area, and then you can get the volume, but you know what, don't those need to go somewhere? Yeah, they do, because they're values that are coming back. So you could either directly print these. I could just say, print, surface volume is, blah, 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 blah. I could do that. Or I could put them in variables. Up to you. Doesn't really matter. Why don't we put them in variables this time? So why don't we just call one variable, let's call it SA for surface area. And let's call the other one VOL for volume. And then let's write a print thing and just say, in plain text, can ones, apostrophe S, surface area is and then what else are we putting in there? Well, SA, that's the surface area, right? And then can one's volume is, and the reality is it's like cubic units, right? And if you wanted to be verbose about it, you could. Then we can do the same thing. We can just actually take all this code, just repeat it. Except we'll just switch it to can 2. We'll use the same variable, doesn't matter. And then we just have to chain a couple things here. Like so. And that should be it, folks. That's enough to test both of them. So we'll create the objects. We'll send the information off as we're creating it. And then all we do is hit the gets to pull back the information, put it on the screen. Let's go ahead and save this and hit the run button. And what has happened to us?
Parentheses after your method calls.
Yeah, that's actually a really good catch. I should have done this. Thank you. All right, you guys are my debuggers. All right, let me run it again. Is that going to change the error message? No. So it says bound method soda can get surface area, blah, 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 blah. Oh, yeah.
14 and 15.
Yeah. So what did I miss? I got to put parentheses here. Because I'm calling methods, right? All right, let's try it again. Better, because I got to fix these two. Run it again. All right, and then if you want to be precise about it, you can do output statements that round it. You could throw after it cubic units or whatever unit you are working with. Whether that math is right or not, I'm taking it on faith, okay?
What exercise is this? 9.5?
This is exercise 9.5, soda can exercise. All right, for these last batch of exercises, we have 9.6 to do, and I think 9.10, I think that's correct. So for 9.6, it says implement a class car with the following properties. A car has a certain fuel efficiency, measured in miles per gallon, and a certain amount of fuel in the gas tank. The efficiency is specified in the constructor, and the initial fuel level is 0. Supply a method called drive that simulates driving a car for a certain distance, reducing the fuel level in the gas tank, and methods for get gas level to return the current fuel level and add gas to tank up. So here's a sample usage. So they're giving you an example of how it's going to work. So they give you an example of like how to instantiate the car as a MyHybrid. Then you'll run a method called add gas, run a method called drive, and then print the output. All right, so they're implying here the car class, a constructor function, add gas method, a drive method, and a get gas level method. So we got to build all of those things. So we better get busy here because time is running out. All right, so first thing we'll do is create a new file. Let's do a save as, and I'm just going to call it car. I'm going to start by doing a little bit of definition here at the top, and blow away all that stuff. So this module defines the car class, and then we will go ahead and actually put the class indicator in here, call it car, and start defining. We'll put in the other definition that they have for the constructor. So for the constructor, we're going to say something like this. And we were told that one of the parameters is going to be fuel efficiency that we throw in, so that's something you pass in right off the bat. So when we run the constructor, remember double underscore here and double underscore there, we're first going to pass in self, and then we're going to pass in fuel efficiency. Make sure you spell it consistently. And then let's define it. So to do this, we are going to set our instance variable. So we're going to start with underscore fuel efficiency. And what's that going to be equal to? Well, fuel efficiency, not the internal one, the one that was passed in. The other thing that we're going to preset is the gas level. So we'll just create a variable, instance variable called gas, and we're just going to set that to 0. So when you create, that's what you're going to start with. Next thing we're going to do is we're going to create the first method here. And the first one we're going to put in here is going to be called add gas. So we're going to do def add gas. We're going to throw in self, which is required, and then we're going to throw in the amount of gas that goes in. Then all this one is going to do is every time you gas up, you're going to gas up with whatever amount you're adding in. So like if I have, a car that's got a 20-gallon tank and I add 20 gallons, I have 20 gallons, right? My car only fits 13. But I have this beautiful effect that it's highly fuel efficient. And so we're going to just add the amount of gas to that. That's all this method does. Next thing we're going to do is we're going to simulate driving the car a certain distance. And so we're just going to write a method that does that mathematically. So I'm going to just call it drive. And once again, it starts with a self-reference and then the distance that you drive. So depending on the distance versus your fuel efficiency, or miles per gallon, it'll tell you how far basically you have gone. So the math here is going to be this. We're going to say self gas equals self gas minus the distance divided by its own fuel efficiency, like so. If it makes you feel more comfortable, this portion really could be put in parentheses, but it's not technically necessary just due to the order of operations. The division will happen first. So like most experienced programmers would leave that off. But if it helps your brain see the math first, so the distance won't get subtracted from the gas, it'll figure out the miles per gallon first and then subtract it from that so you get the right value. Hopefully that makes sense. Last thing that we need to do is have a method to return the gas level. So we'll do that like this. So we're going to define another method called get gas level. So how much gas is left in the tank is really what this is doing. let's put in our colon here, and then all we're going to return here is wherever the gas level is currently. So what is left? That, folks, completes the car class file. We have a constructor. We have the three methods that they indicated. The actions are pretty simple inside here. So now we need to write a demo program. All right, let's move on now and create the demo program for this. I'm going to create another new file, do a save as, and we'll call this demo car. All right. This is going to be painfully simple. You know why? Because they already gave us the code. The only part that they didn't give us was this, and that is from car, import car. Okay? And then they simply give us like the same code they gave us in the book, which was the example of how we would test it. Okay, fine, we'll use that. So we're going to give it a car that's got an MPG of 50 miles to the gallon, which is amazing, right? And he's calling it My Hybrid. So he's creating an object called My Hybrid with all the features of the car class. Then he's going to add gas to the car because when you first create that car, it starts at 0, right? So the first thing you have to do is put gas in. So we got gas. And then we drove it 100 miles. And then it'll tell us how much gas is left. All right? I'm going to save this. And don't worry, I'll put the other code back up on the screen in a second. Let's go ahead and run it and see what happens. So if you have a car that's got a 50 mpg capability, did I do this right? I think so. Oh, okay, so, yeah, so how much gas is left? 18. So if you figure this out really carefully, if I start with 20 gallons, right, and I drive 100 miles, 100 divided by 50 miles per gallon, I used up 2 gallons, so how much do I have left? I have 18 gallons left. Now, I'm gonna mess with this a little bit because you buy hybrids, and a lot of people are buying hybrids these days, right? And I'm a big fan of diesel vehicles because I own one. And so the fascinating thing about a diesel vehicle, even though they've gotten a very bad rap lately with emissions and stuff, is actually, most hybrid cars really don't even get that much. They usually get like 40 or 45 if you're lucky. My diesel, and mine is really old, it doesn't even have that great of performance anymore. I regularly get 46 mpg with my diesel. It's not a hybrid. Granted, diesel costs a little bit more. But let's run this too. It is rounding the gallons. Are you guys noticing that? All right, very simplistic example, but there you go. But I did want to show you that it is rounding it. And the truth is, in my car, I only have a 13-gallon tank. And I think this is always fascinating math if you calculate it out. If you get a 13-gallon tank and you get 46 mpg, yep, that's about what I get. I get 600 miles out of one tank of diesel. And for the amount of driving that I do, you guys, I get almost 2 weeks worth of commuting back and forth to Milwaukee on one tank of fuel. Compare that to my wife's Toyota, big SUV. It probably costs 4 times as much Because I don't think that thing even gets a 20 mpg. It's like I drive around the block and it's down a quarter tank. Not that that's really the lesson here. So there's your demo file, and you can throw in as many demos as you want. That's kind of the point. Here's the car class. Am I okay to move forward, you guys? Okay. Our next exercise, I think, is 9:10. Is that correct? Oops, and I passed it right here. All right, so this one says, implement a voting machine class that can be used for a simple election. Have methods to clear the machine state, to vote for a Democrat, or vote for a Republican, or vote for impeachment. I mean, that was a bad political joke there. Or to get the tallies for both parties. All right, so let's get busy on this. This one will actually be pretty easy, and this is our last exercise, which is wonderful. I'm gonna just make sure I look at the right chapter here. It's exercise 10. All right, so for as simple as the description is, there's a little bit of work to do here, so let's take this one piece at a time, as we have been. So first of all, create a new file, do a save as. And I'm going to call mine voting machine, because, you know, I think that's what I told us to call it. So I'm creating a file called voting machine. I'm going to start with some definitions and a class declaration. So we're calling it class voting machine, capital V, capital M. We're going to begin with the constructor. And all it wants us to keep track of is how many Democratic votes and how many Republican votes, right? Never mind the Green Party or or anything like that. Yeah, independents. Don't forget libertarians. I'm trying to have a little political cynicism here, but it really isn't important for what we're doing. All right? So that's the constructor. So the init method is the constructor. The next thing we need to do is we need to have methods for voting for Republican and voting for Democrat. Those are pretty simple. So to vote Democrat, I'm just going to call it vote Democrat. And all it's going to do is increment by 1. And heck, if vote Democrat's that easy, vote Republican's just as easy. So let's copy that in. And then just change it to Republican. And then we'll change this to rep count and this to rep count. All right, not too bad. The other one that we need to do is we need to get the tally. So in other words, return the total for each one. So we can create another method called get tallies, get totals, whatever you want to call it. Returns Democratic count, returns the Republican count, in that order. And then if we want to use this voting machine more than once, which might be handy, let's also put in a reset method, so it resets things back to 0 when we're all done. That, folks, is the entirety of the voting machine class. So we have all the methods they told us to build. Vote Democrat, vote Republican, get the tallies, reset the count, and also the constructor function. All right, now let's go ahead and create a demo program to test all this. And this should be a piece of cake, given all the experience that we've built up now doing this. So let's start by doing a save as. And let's call it demo vote. I think that's adequate. I'm going to get rid of all the stuff inside here, and I'm going to begin with telling people what this is going to do and doing our import. And I think we got an issue here, right? Or did I? No, I actually called it voting machine, didn't I? I thought maybe I called it something else. Right, we will need to create a brand new voting machine. So we're just going to instantiate it. I'm just going to call it VM. That's all it takes to create it. So it's a brand new voting machine with 0 Republican votes and 0 Democratic votes. And no hanging chads. Then I'm going to go ahead and I'm going to cast some votes. I'm going to just force it to run. And so, okay, so there's no political preference here, by the way. This is just the way I'm copying it from the author's solution, just so you know. So if he's voting more for one party or the other, it's not my fault. All right, but you can see he's voting a few Republicans, a few Democrats, and then we need to check and see if it worked. And so we're just going to do a printout of the totals like this, and we're going to get the tallies. One thing that he didn't, this is as far as his example goes. And then I say to myself, well, hold on a second. We tested vote Democrat, we tested vote Republican, we tested get tallies, but what's the one thing that we didn't test? The reset, right? So I'm going to run a reset. So I'm going to say VM dot reset the parens that clears the votes, right? So I'm just going to do another print statement here. I'm going to say votes cleared. And then, you know what? I'm going to put in an escape there to put an extra line in. And then I'm going to run some more votes, but I'm going to mix them up a little bit. Let's do it like this. And then do the output again. So my point is, I want to test reset, put more votes into it and see what the output is again. And then all you have to do to really see if it's right is just basically count the number of votes for each one in each bunch there, and it should do it. So let's go ahead and give this a run and see what happens. All right, so the first one, 4 Democrats, 3 Republicans, is that right? Yep. And then the votes were cleared. And then 2 Democrats and 4 Republicans, that's right too. So I saw a little flaw in what they were doing, and the flaw that I saw was they were putting in a reset method, but they weren't testing it. All right, so those exercises really aren't that bad, you guys. It's just a matter of understanding how the mechanics work, and then once you get the mechanics, it's a piece of cake. The one that you guys have assigned for your final exam is right along the same lines as this. So you're going to create a class file, and you're going to create a demo program for it. But the demo program's got very specific instructions. All right, this video will end here. Class is officially done. So this video is done.